So after we discuss about the array implementation for the list, and we look through the constructor, basically create a space, specify the array name, capacity, as well as the size initiate equal to 0, we will be able to create an empty function, which is a Boolean function to tell us whether or not this array or list is empty. And then we will be able to look into the traverse, basically write a for loop to print out every single items in the array to show the items stored in the list. Therefore, let's take a look of the insert implementation. By using the example, you will understand that for the insert operation, you need two parameters. First parameter is the value that you want to store it into the list. Whatever the value that is, it can be an integer, it can be a floating point, it can be characters, it can be names, grocery items, whatever it is that's related to your list. Besides that, you also need to indicate where you want to insert. The location do matters over here. And therefore, you can see that originally, if we have a 10 item list showed over here and we want to insert some values into the list, it does not have to be sorted. It just happened that this example is a sorted example. You can, of course, insert 6 into index of 4 or insert 10 at the index 8. Now, saying that I want to insert value 56 at the location of 4, the end result for this operation should be have all the values from index 0 to 3 still stays untouched, and then insert the value of 56 and shift every item one space to your right. And therefore, this is what we want to implement. You can see that this gives a more concrete picture of how the whole process is being done. We need to insert our value of 56 at index number of 4, and then everything else need to be shifted. Of course, by looking into the shift operation, you would know that there is a loop that's required for this operation. Depending on how many items that you need to shift, the cost of this operation is going to be big O of n operation. Because it's possible that you want to insert the items in the beginning. That means every single things that you have in your array need to be shifted. Of course, the best case scenario is that you want to insert something in the end, and therefore no shift is necessary. However, if we look into an average case, we need to shift about half amount of n items, and after the big O notation, you know this is going to be a big O of n operation. So let's take a look of the code. Algorithm for insert, it will take two parameters as we mentioned. You need a value and you also need the position of where do we want to do the insert operation. So before we do any insert, we need to check for two things. First of all, if the size is equal to capacity. What that's trying to say is that if the size indicating the items that we have is equal to the capacity of the array, means it is already full. Because all the capacities, say 10 is the size that we have, and 10 is the capacity that we have, and we already have 10 items, then it is indicating you cannot add one more item. Otherwise, it's going to be a full situation. If position is less than 0, indicating that you want to insert something in a negative index, that's obviously not going to be correct. Or you want to insert some locations that's greater than size, that will break the continuity of the array. So you need to make sure the position is within the size operation so that it will be able to have a successful insert. And therefore, if someone wants to do something weird, then you need to have an error message showed up and indicating that's not a proper operation. If none of those occur, which means that it's a valid operation for you to do the insert, then what we need to do is this. For I in range, so a for loop occurs. Now here is the special part. you need to do from size to position plus 1. If you understand correctly, you will understand that the size is actually at the end of the array, which is indicating actually one space after the most high index of your list. So we will go backward until position plus 1, and when we were moving forward through those positions, we are going to copy the values to the locations. So if we go back to the slide, you will see basically we start with this index, because if we start with the index of 0 in the beginning, and when you go over here, this index will be size minus 1. And this is going to give you the index of the size. So we're starting with this size index. We copy the value into this position. And then we move to the next one. Use 91 to override 99 and use 89 to override 91. So basically when we do that, you will see our loop over here is actually going from the end back to the position plus 1. Because if we hit position plus 1, that means we have successfully shifted everything. We have successfully shifted everything one space, and all we need to do is that we need to add one, put the position, put the item into that position. And in the end, don't forget to do size plus plus, indicating you need to increment the size by 1. So let's take a look at this one. You can see that when we do this case, we have index from 0 to 9, indicating that the size equal to 10, which means we have 10 items. And then when we try to do the insert 56 and 4, the same example, when I is equal to size, you can see that we copy 99 into this position. At this moment, you have 299 over here because you simply copy and paste one values over there. And when we move I to 9, go backward, we copy 91 to 99. So you overwrite 99 by 91, and at this moment you have 291. So next things, we move I to 8. So now we have 289 because we move 89 over here. And when 87, when I equal to 7, we have 82 overwrite over here. And when we have I equal to 6, we have 79 override. So we have 279 at this moment. And then I will keep decrement to 5, which is equal to position 4 plus 1. So that is the last thing that we need to do. So you can see we have 261 over here. And finally, we are going to put 56 into that position, which is 4 over there. And then you can see that we can successfully put 56 over here. And don't forget about size plus plus, indicating that you want to do the increment of the size so that you have a correct amount of the size value. By doing so, okay, the efficiency of this insert operation obviously depending on the number of array elements that you have. So in the worst case scenario, you need to shift everything. So you're going to give you a linear operation. For the best case scenario, it actually gives you a constant value, but of course we cannot expect the best case scenario in this problem. However, the next topic that we want to discuss are actually the special case of the list, which will have what we call stacks and queues to have special scenarios that because of the design of the problem, we can achieve big O of 1 instead of big O of n, and then do something very special. So we will continue after this topic. We will talk about stack and queue directly. To do delete operation, it also requires a shift. So for example, in this case, we already have all of these items, and then we want to delete the index of one item. Then we need to shift everything one space back, and that will still require a big O of n operation. You may notice that this 99 still stays here. It is there. However, while we do size minus minus in the end of the delete operation, we will never be able to access this location anymore. So that is something that we want to look into. Because once we do size minus minus, think about this. If we try to hit the display operation, it will show from index of 0 until size minus 1. So it will not print it out the last item. If we want to do insert, the items will be overwrite over here. So this space will be overwrite by whatever values it is. And if we want to do the delete, which is the code that we will see pretty soon, is that it will go back over here. So although there are some values stored in the space, we will never be able to access anymore. Let's continue looking into this. Algorithm for delete, which takes position as a parameter. So unlike insert, the delete operation takes only one parameter, which is the position, indicating where you want to do the delete. So if size is 0, this is very easy to test. You can write the if statement to test if size equal to 0, or you can use the empty function. So this should be very easy. What this line trying to say is that if the size is equal to 0, that means there's nothing there and you are not supposed to delete anything. Position, we do the same thing about the check-in. It cannot be negative values and it need to be winning the size value. So if that's the case, if the position is negative or position is greater or equal to size, then it is wrong. So we need to show error message. Otherwise, it's pretty straightforward. Starting from the position that we want to do the delete, we are going to take the element of the next location stored in the position specified. And we will keep doing that until size minus 2. Why size minus 2? Because the last location originally is size minus 1. After we delete one more location, it will become size minus 2. While we're doing that, we simply put the value in the next location into the I location that we are looking, and then in the end, remember to do the size minus minus so that you will be able to have the correct size check. So let's take a look at the delete example. Originally size equals to 10 and say now we want to delete 4, which is this location index of 4. So what we are going to do is that we're going to put 79 into this location, and then I will go to the next location. So we will go into this location, put 82 into that location. So you will have 82 over here. And then when I move to 6, we will going to take the next location 89 into this spot. And then when I equal to 7, we will put 91 back into the index of 7. And then when I equals to 8, that's exactly when size minus 2 happened, because originally size is 10. And when I equals to 8, which is size minus 2, we know that is going to be our last operation that we need to do. So we put 99 back over here. This can be the end of it, because after this operation, we will do size minus minus. So the size will become 9, indicating index of 8 is going to be the last locations already. Of course, if you don't feel comfortable that 99 is still there, you can totally, before you do size minus minus, you can do a index of the size minus 1 equal to negative 1. You can add that line with or without that line. It's going to do the same thing. And therefore, this is the operation for the delete. The computing time of such function again relies on the big O of n. Big O of n is the worst case and big O of 1 for the best case scenario. In the problem of the list, average case, which is n divided by 2, is what we are expecting. So take a big O notation, we're still looking at the linear operation for insert and delete using array implementation. We will be able to look into the spatial scenario like I mentioned in stack and queue, and then actually having a good performance over here. Since we finish about the array implementation, the next things that we want to look into is going to be the pointer and the linked list implementation. This is going to be a very important topic for you to understand throughout the semester, because more than half of items is going to relate it to the linked list implementation.